Guess what, folks? We goofed. This is the point where we left off in the last video. I assumed that was the empty loaded state. It was not the empty loaded state. So we'll have to do that whole experiment over again. And you ask yourself, how can one possibly obtain more amperage out of a device than the amount of amperage that you send in? Well, we got some answers for that. And we got some answers for Joseph P. Farrell too. We're going to look at this state right now, which is with one load attached. The load that's attached is that 2.4 Henry coil, and we're going to show you the ringing of the bell on this video instead. And we're going to show you how, in fact, the 666 machine sends magnetic fields into the future. We're even going to provide corroborating evidence with a two-channel oscilloscope. Now here in this situation here, we're going to look at this situation real quick. We got 30.9 volts in between 10.6 and 19.4. There's clearly more voltage being read by that middle point between those 2 points of reference. 30.8 exceeds those two values added together. Also on 2-3, we see that 23.1 sums to greater than the sum of these two source voltages. And the only voltage that's under 180 degrees is 7.9 volts between those. Now we go to the law of cosines. We'll briefly look at. There's the rules for the law of the cosine. So since we already got two phase angles over 180 degrees, we only got one to examine, and it's already 360 degrees or over that before we even examine that one. And when we, as I said, the law of cosines, when we apply the law of cosines to that phase, we find that we got 29.55 degrees. So we got 30 degrees over 360 degrees. How can this be possible? Well, what I decided to do was to take Joseph P. Farrell's book and do the same thing that he talked about with Carlos Allende. And what I've done is I've taken his book and started scribbling all my notes in there. This one's kind of amusing. And what it says, a phase shift into the future. Whereby the effect seemingly occurs before its own cause. Surely, nature will not allow this to happen. Seeing that with a 6-phase system and a Hans-Kohler hexagonal coil system, we can indeed conclude that the vector summation of both the Lenz law and line effects places the magnetic rotation ahead of its actual phase rotation in space. But relative to its own derived voltage source, all the usual time laws apply. You see that M with the circle around it? That means that's a mistake. All the usual time laws do not apply. Now we're going to look at the scoping on one of these readings, on one of the phases, and we're going to find out that the top signal is the source, and we've got the effect as the bottom sinusoidal signal. The effect is coming out before the cause. The smaller coil reaches zero polarity before, in time, that the source voltage tells it to go to 0. Now we'll look at the differences between these derived signals. We can always tell what the source signal is because of the unusual shape of its wave. It's not purely sinusoidal. We'll go and look at channel 1. Signal is more triangular than it is sinusoidal. That's the source voltage. Here's the resonant rise voltage. Resonant rise voltage is on a 5x probe. It's clearly sinusoidal. And here's both signals in time. And what we'll do is again enlarge that so we can see the relative time differences, and clearly the effect is preceding the cause, and as a consequence of the effect preceding the cause, we must conclude that the magnetic fields are being sent into the future, since the magnetic fields are appearing in time before the command to do so appears. And that's about that for that. We're going to go and show you the true unloaded state now. But it certainly does explain a lot of things. We're sending magnetic fields into the future. I should get the Nobel Prize for this one, buddy. I'm telling you. And as a consequence, then we're getting more voltage between the points of reference than can possibly exist. Now we're going to try to do the ringing of the bell experiment, show a few more things, and call it quits. Now we've got present condition, the 2.4 Henry coil has 7.6 volts across it, and it's enabling 7.8 amps across it. We're going to take that coil off, its coil, now we can see we only have 3.8 volts enabling 10.3 milliamps. Now the concept of a load powering its own source, there's no load on that coil magnetically. When we power things through air core methods, we usually always see that the vibration or the amount of amperage of the sending coil is reduced when itself imparts vibrations to the other coils around it. So that's what we're going to do here. We're going to put that coil on there and impart a vibration to the large inductor. Right now the large inductor is the 68.5 Henry coil. And we're going to look there. We're going to put that coil on there. And we notice that it dropped to 7.3 milliamps. You see that we got 1.22 milliamps there. Now we're going to go to the third coil, which has the water capacity and resonance in its core, and we're going to attach that third coil. We got 1.25, dropped to 1.14. We lost 0.10 milliamps, but yet we have gained 0.83 milliamps on the extra coil. Now we look at our source. Our source has barely changed. Call that quits for now.